Hello everyone, and welcome to this new demonstration video. Today, we are going to try to demonstrate one of the most famous equations in physics, known well beyond scientific circles, E equals mc². This equation establishes a direct link between mass m, energy E, and the speed of light c in a vacuum. Before entering the demonstration, do a historical look at the concept that allowed Einstein to achieve this scientific revolution. In 1895, Hendrik Lorentz introduced equations describing the transformations necessary to relate spatial and temporal coordinates between two frames of reference in relative motion. These transformations, purely mathematical at the time, were further developed by Henri Poincaré, a French mathematician in 1904. Then, in 1905, Albert Einstein gave them a physical interpretation in his theory of special relativity. He showed that these transformations explain two fundamental phenomena: time dilation in a moving frame of reference. Time flows more slowly, and the contraction of lengths in a moving frame of reference, objects appear shortened in the direction of motion. Einstein thus revolutionized our understanding of space and time. He replaced the classical Newtonian view, where space and time are absolute, with a relativistic view, where they depend on the relative motion of observers. Before Einstein, classical mechanics used Galilean transformations to relate two reference frames. For example, if a train is moving at a speed v, and a passenger in that train is moving at a speed v prime, an observer on the platform would see the passenger moving at a speed of v plus v prime. However, when the speeds approach that of light c, the Galilean transformations become invalid. This is where the Lorentz transformations come into play, as they adhere to the fundamental postulate of special relativity. The speed of light is a universal constant independent of the observer's motion. In 1900, Max Planck discovered a revolutionary solution to the problem of the ultraviolet catastrophe, a theoretical paradox that appeared when attempting to describe thermal radiation with classical physics. Planck proposed that the energy of electromagnetic waves be quantized, meaning it can only be emitted or absorbed on discrete packets called quanta. He established that the energy of a quantum is proportional to the frequency of the wave, according to the relation E equals h nu, where h is Planck's constant, and nu, where f is the frequency of Landé. This result marked the birth of quantum mechanics. In 1905, during his miraculous year, Einstein used Planck's idea of quantification to introduce the notion of the photon, a particle of light, and explain the photoelectric effect, a phenomenon where light removes electrons from a material. The same year, Einstein published his theory of special relativity based on two postulates. The laws of physics are the same in all inertial frames of reference. The speed of light in a vacuum is a universal constant, independent of the movement of the source or the observer. He also refuted the existence of the luminiferous ether, a hypothesis that light would need a material medium to propagate, like sound waves need a material medium such as air, or mechanical waves like water. For example, the Michelson and Morley experiments in 1887 had already shown that this ether does not exist. But it was Einstein who drew the definitive conclusions. To demonstrate the equation E equals mc², we will need two fundamental relations. The first concerns the energy of a photon, given by E equals h nu, where nu is the frequency of the photon, which we can express depending on c and lambda, with lambda being the wavelength and c is the speed of light. This result is based on the wave-particle duality in quantum mechanics, which states that the photon can be considered both as a wave and as a particle. We will also need the Lorentz transformation formulas, which apply in a reference frame moving at a velocity v, as mentioned in the historical context. Let's start with a thought experiment, as Einstein did. By the way, this demonstration is a simplified version of the version found by Einstein or imagined by Einstein to demonstrate this relationship. So, we will imagine a box or a machine capable of producing two photons. One is directed to the left and the other to the right, both at the same speed c. Let's suppose this box is initially at rest. So, its speed is 0. The two photons move in opposite directions. Opposite each have a momentum p given by p is equal to h over lambda, where h is Planck's constant, lambda the wavelength, and their energy is given by E is equal to h, mu is equal to h, c over lambda. Therefore, when the two photons are emitted, the box loses an amount of energy corresponding to the emission of these photons. Thus, we can write the variation of the energy of the box as delta E box is equal to minus 2 hc over lambda. Let's now take the second case, assuming the box is moving to the right with a constant speed v. This means that the box follows the photon moving to the right in this situation. The photon emitted to the right will be observed with a blue shift, which we call blue shift, and the photon emitted to the left will be observed with a red shift, the red shift. This is a manifestation of the Doppler effect applied to light. This same phenomenon was used by Edwin Hubble to demonstrate that the universe is expanding. Now let's associate a specific wavelength with each photon. So the blue photon, it will have a wavelength that we denote as lambda b, and the red photon will have a wavelength that we denote as lambda r. Since according to quantum mechanics, the photon is described by the wave-particle duality, we can also associate it with a sinusoidal propagation function in the form of sine of pi over lambda x minus ct, where x minus ct represents the argument responsible for the wave's propagation to the right. In the case where the box is moving, it is necessary to take into account the transformations of the coordinates of the reference frame of the moving box. This implies replacing x minus ct with x prime minus ct prime using the Lorentz transformations to express the relation between xt and x prime minus and x prime t prime. By applying this transformation to the sinusoidal function, we obtain a new relation for the wavelength in the moving frame of reference. For the blue photon, this wavelength is given by lambda b. Lambda prime is equal to lambda over gamma 1 plus v over c. With gamma, it is the Lorentz relativistic factor. We perform an approximation by assuming that the speed of the bat is much less than the speed of light, and so we can expand the gamma term to the first order, so a Taylor expansion, and we find gamma is equal to 1. Thus, to the first approximation, we find that the momentum of the blue photon shifted to the right becomes p is equal to h over lambda times 1 plus v over c. Similarly, for the red photon, moving to the left, the momentum is given by p equals minus h over lambda times 1 minus v over c. Here, we have the minus sign since it is moving to the left. Now, we will calculate the change in momentum of the photons. So it is 2h true on the wave AC. Now, we have the conservation of momentum between the box and the two emitted photons. So, delta p box is equal to minus delta photon, and we find minus 2hcv over lambda c. And the change in momentum of the box since it moves, so it's delta mv. V is constant, so what changed here is the mass, and thus, plugging that in, we find that delta m is equal to minus 2h over lambda c. So delta m is equal to minus 2hc over lambda times 1 over c squared. Now we will write that 2hc over lambda is the variation of the energy of the box that we calculated previously, divided by the speed of light squared. And so the variation of the energy of the box is delta mc². And we finally find that energy is equal to mass times the speed of light squared. And there you have it. We have just demonstrated the famous equation E equals mc², one of the greatest scientific revelations of all time. This equation connects mass and energy in a profound and universal way. Thanks to this relation, we understood how the energy of stars is produced, how nuclear reactions work, and even why the universe as we know it is possible. It has literally changed our view of reality.